Welcome back, guys. So, today, let's see where we left off yesterday. And it should be somewhere here. And I wanted to say, in yesterday's stream, for some reason, my streaming platform just gave up on me, and half of the time, my screen was not recorded, but my voice was recorded, so it's just a huge mess. Hopefully nothing like that happens today, so I'm gonna just have a check on what's being shown on the screen sometimes, maybe at least once in 10 minutes, 20 minutes, just to check if things are going well, maybe for this theme. And if it goes well this time, I think I don't have to worry about it next time. Yeah, that's how it's gonna be. So now let's dive in. Where did we leave? Yeah, so we wanted to create the helper, and that helper needs to be general enough to be, and it's going to be like a early helper. It's not like the actual kernel malloc or something. It's like the helper that will be used by high level helpers. So in general, we are gonna assign a memory location inside the linker script, so we know that this particular location is not used by anyone else. And we just want to use this for our bitmap. And if you check out last previous video, we have went through why we need a bitmap, because exactly that's the whole point, because we have a virtual physical range that we want to track, and there are lots of helpers who might want to allocate into this mm, physical address, physical range. But we need to make sure that um, someone has to keep track of which zones or which pages in the physical RAM is being actually used, and who is using that, something like that. That's the whole use case of this helper. This no matter who it is, they are gonna go through this, and this helper is going to just directly give us the information about what are the pages that are currently in use. And you can also ask it to give a new page that's not currently in use, and it's just going to give you that. That's what I wanted to do. And yesterday we were first of all trying to allocate the bitmap, because bitmap has to be stored somewhere, and that's why we allocated this particular memory region. Now we need to call that from here, and that's exactly what we are doing here. But before that, we also need to get the total RAM, and we tried to do that, and it was going just fine. But turns out that I need to allocate those pages, because the actual physical RAM has to be read from 4000 range. That is just 4000 range, and for that I need to map that into kernel page, into page tables, if I want to use that from kmain. So I changed the design a little bit, and I have actually called it even before we enable MMU here. And I'll just write the value to this address, because this address is mapped. And I'm going to initialize MMU, and I'm going to jump into kmain, and here inside the kmain I can read that value. It was just fine yesterday, and it did work. But turns out that because likes to have it as little Indian, we need to also switch bytes, and that's what I'm going to do right now. I just want to make sure. I know that there's a there's an uh, instruction, arm instruction to switch reverse NDNS, and we did see it last time. So this is exactly what we want to do, and we have to give what do we have to give? We have to give the x0 to x1, which is the source, which is the which is the source operand. Oh, okay, so source is here and destination is here. Okay, so we can do that here. Once we write that, once we have written that, well, I guess we can give both the addresses same value, but yeah, let's try x0, x0. Let's see what happens, and let's build it. Bash build. Holy fuck. Oh my fucking god, I just updated my MacBook recently. Probably that was the issue. Press enter to display the license. I pressed enter. Now type agree, you fuck me. Oh, what? Something is missing? What's missing? Oh fuck, I removed a lot of things yesterday. Oh my god, I messed up the entire setup probably. Okay, what do I need? I need readelf. Okay, that is not bad. We can install it. Okay, even without that it's still working. Okay, GDB won't work. We need GDB. Okay, let's just fucking install it. Mac OS. There's no readelf. Where do you exactly look for that file? Oh, unnecessary debugging. Still, it's fine. And I remember installing this, but do I have readelf? Don't have it. Okay, maybe I can just say install readelf. Not sure if we have it. I'll try. It's going to update every fucking thing, and it's going to say what did it say? Searching for similar name, so it didn't find it. fucking. Okay. Missing read elf. Then how the fuck did I install it in the first place? It's arms elf. I need a arms elf file. Okay. Okay, I guess pinutils arm. I did do something. I don't fucking remember what I did. Wait. Star GF. Okay. So read elf is used every damn where, so we need it. Without that, we're not getting anywhere. These are the file things it's currently using. Maybe GF has this. What about dependencies? What about fucking dependencies? Oh shit. Read elf. Port install bin utils. Yep, this is what we have to do. I knew it. I knew it. But how the fuck did I remove this? I don't remember. There's no readelf. Maybe I have to give the location. Mm, yep, yep. I understood. I understood. I guess I recently was fucking with my ZRH file. Probably that's why it fucked up. Source dot Z src. Okay, now, yep, now we have readelf. Yeah, I was changing stuff inside that file. I saw some empty things, so I removed it. I believed that this was also an empty thing, but turns out, okay. Anyway, it's working now, so we're good. Okay, what do we do now? So, where were we? We were about to check if this reverse worked or not. Okay, let's see. The total RAM is still 0, so it didn't work. So we'll try again, and let's stop at get. No, we can continue it. No, my god. And I just get into get total RAM and I type finish. What is the shorthand for shorthand for finish in GDB? Why the fuck there? I could have just typed it here. GDB. You fuck. Finish GDB. Fin. Now we are out of that, and we are about to move the address, so we can step next of it. Now we can info register x0, and you can see that the value is there and it's correct. Now let's see after the rev operation. What the fuck? What the fuck? Maybe I'm thinking about it in a wrong way. I'm assuming something that's not there. We have an address, and that address has this value. I have a fucking question. If it's a 64-bit integer value, and if it's in an address, how exactly will it be laid out? It'll be from least significant bit to the most significant bit. So it should be 64-bit aligned. In that case, in that fucking case. What the fuck? If it's 64-bit aligned, I think it should just work. Maybe something's wrong in my end. Here I'm trying to say that this location has an 64-bit value. Oh, well, let's break UART printf and let's continue. Seems like it does not want to print stop at that location. Okay, fine. Okay. If I take this as UR32, what would happen then? Would it work? Nope, it didn't work. Okay, man. Wait, first of all, why the fuck it is not stopping at K-main? What the fuck? Disassemble K-main. I know why it's not stopping, because of MMU. It's because of the fucking MMU. K-main. And this is the starting address of K-main. What we can do is I think I have used 3 Fs. I believe so. No, it's 4 Fs. We can just change it to and put a breakpoint there, and hopefully it'll stop. And it did stop. That's good. That's fucking good. Now if we SI and then type finish, it does not have any out of frame, so we need to manually get into it. Then let's just let's just kill it and try it again and disassemble K-main and see where exactly do we write it. Here, let's just start 1 2 3 4 1 2 3 4. Now we should be able to break at the correct location. We can move forward, and now let's check what's in this location. Let's see. Maybe that's true, because I'm not supposed to directly read from, but I have identity map, so it should work. Let's see. 80 8 0 1 2 3 4, and it's 0 2, it's 0. No, reading the wrong thing. 1 2 1 2. Maybe down the line someone is overwriting this. Who the fuck overwrites this? That's why I just took a random address, hoping that nobody would touch it. Fuck me. Maybe we have to use our stack. That's the only way, I believe. We need to use our stack. Shit. I didn't want to pass anything, but fine. You went total RAM. Hmm, 64. And let's comment this out. Let's type total RAM. Now we have to pass that value to kmain. How do we do that? We go down here. We don't have to do this exactly. What we have to do is store this into something that won't be used. So let's say we store it here. So we don't need this. We can load from LDR x0, because x0 is the first argument, I believe. Yep, I am pretty sure. So okay, let's see. Okay, we have already moved it. Okay, now let's try it. 80. Okay, so something is overwriting it. That's why it's fucking not there. Oh, fucking hell. Who the fuck overwrites that? I just chose that memory randomly. Nobody is supposed to write to this fucking location. How the fuck did they write to that? Okay, we'll just write to register Which ARM register can I use to store something that won't be usually changed, usually used by function calls? This is fucking stupid. I'll use X10. Move. Which is the source, which is the destination? I have no fucking clue. Move instruction. Where's the move? Where is the move? Where's the information about operand structure, you piece of shit? Move instruction operands. Move immediate register to register. Which is the source? You fucking. Okay, so RD is always destination. Fine. Where's RD? I'm here. So destination should be X10, but if I use X10, am I sure that it won't be used by other functions? Oh, fucking. Or I can push it to stack and pop it. Oh, that should work. Is push to stack. ARM instruction. You just put push, that's it, nothing much. Push X0. Hopefully it's not using, I don't think it uses stack, so we can pop it. Pop top of the stack into X0. Oh, we'll have to use it in this way. Okay. There's just no fucking pop. We have to use LDR X0, take from SP and shift the pointer by 8. Okay, now let's see. What the fuck? There's no fucking push. You just told me that there's push. What the fuck is this? Oh, I can only do this. Maybe I should fucking read what it's saying. I just want to push an instruction into stack. Push an instruction, not an instruction. I just want to push an register. Fucking. Oh, this is what I want. Let's do that. Store x1 x0 into sp minus 16. Why do I have to put minus 16? I don't know. Maybe it's a prefix. It's like I plus plus or plus plus I. Who cares? Let's first of all get it working, and then we can think about the rest. Info registers sp. Stack has this on top. Okay, now let's see if stack has. No, it doesn't have that. Oh fuck me. Maybe I should just put 8. Oh fucking crap. Oh, why the fuck do we cry so hard to even push it to a stack? How do I... Stack is pointing to what? What the crap? Oh, fuck me. Why the fuck do I write code? Oh, fucking. Neons. What's info registers sp. No, if I put stack has nothing whatsoever. Why can't I fucking write to the stack? Push to stack in ARM64. So you can only push two things at a time because stack needs to be pushed 16 at a time. Okay, so let's push both x1 and x2. And x1 supposed to have the thing. Now if we invoke this, why? What the? X0. X0 has the value and x1, what does x1 have? X1 has some random value, but I used STP to move everything to SP. Let's put SP minus 16. Oh, it is in the top. But the SP is pointing to this. Why is that? SP minus 16, I have the proper value. Well, let's just use SP minus 16 and take the value out of it, nothing much. But by then I hope we don't use anything here. Instead of LDR, let's just try LDP x0 and x1 from SP 16. Let's see. We have it. We get into it, and what do? We finish it. Now we are back outside. Let's see what's in there. We have completely fucked up the stack. So we cannot use the stack because we don't properly clean up things there. So stack is not the right way to store this. How the fuck do I store a value and use it in fucking ARM? Let's choose something beyond everywhere. But if I choose that, then I have to add the page tables for that. That's just so fucking annoying. What's the proper way to do it? Think. Ba, 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 ba. I have no fucking clue. Let's see which register is not used. That's the way to go. We'll finish this and we'll SI. Before that, let's try info registers. There's so many fucking registers. Oh my god, we could just use hopefully X13. Let's see. X13 does not seem to be used before the function. Now let's see if we SI and fin. Now if I try registers, okay, still 13 is not used. That's good. Now here if we try for registers, well, 13 is free. Let's just write it to 13. Hopefully this fucking hack will work. I don't know when this is gonna hit me back and I'm gonna fucking wonder why the fuck it's not working. But it's fine. It's fine. Destination is X13. Source is X0. Now if we run it, and finish it, and I put info registers. No, I can just put info register X13 and I have it, and I press this and finish it, and I double check if it's still there, and now if I try again for registers, it's there. So hopefully we can use this fucking thing. Move x0 from x13. Now if we try it, finish it, try it, and it's correct, and finish it, and try it. And now if we try x0, okay, it's in the correct address. So now let's try this. Yep, allocation fails. Something failed, but at least something is better. At least we have a new thing, new year. So that's good. So something is happening. We have total RAM. Why is total physical RAM 0 but the bitmap size has some value? That's a fucking interesting thing. So it's let's run this and try disassemble, and let's copy this location and B start, try it. 1 2 3 4, 1 2 3 4. Now if we continue, we should stop there, and if we info register 60, it's correct. X0 value is correct. Okay. I think it's the second next one. It's correct. Everywhere it's correct. But now we try to pass it down to mem block, and if the mem block size is more than 512, it's it will say it's error. But why is it more than 512? And the bitmap sizes is fucking 13. Total physical RAM divided by, wait, let's do the calculation. It's what's my total fucking RAM size? I don't know, I fucking forgot. It's 4 GB. 4 GB divided by 4096 bytes. Okay, this divided by 8. Okay, this bytes to MB. No, bytes to KB. Not bit, you fucking piece. Okay, it is correct. Then why the fuck do I have it like this? Bitmap size is correct. But I'm missing something. This is the bitmap size. And how much did I allocate? I have allocated something here. What exactly? Let's go back to the basics and think about why are we here. Let's just get it straight. We want a bitmap. Why do we need a bitmap? Because we want to do this. Let me write it down here. So it's like 0th bit. If we set the 0th bit, that means the page 0 is used. So, and if I set the 117th bit, then page 117 is used. Currently, in our case, 4 GB RAM with 4 KB page would take 1000 something bits. This is the calculation. Fine. Now we have to make sure we allocate that space. Five 12 into 1000, so it will 1 MB is 1000 kilobytes, so it's 512 bytes. It's like 512 KB. So we have to check it like into 4. So we know that it is not used, and if I run, why is it still fails? Why the fuck? What the fuck? Norris and Piastri disqualified from Las Vegas? Oh. That's interesting. Interesting. It's out of topic, guys. It's your fun. Sorry. I just got a notification saying that that fucking PS3 is out of the race. So it's just 24 points. Huh? Interesting. Okay, so that's out of topic. Let's just see again. We have a size, and let's just do this math here. 512 KB into bytes. Into bits. Oh, fucky. Yeah, we'll just put 512 KB into hex. Okay. And hex to decimal. This is the fucking decimal number that we are trying to use. Now let's see. If we continue. Why the fuck allocation still fails? It's 1313072, right? If the size is greater than, oh my fucking god, 1237. Oh, maybe this U62 is fucking with us. Maybe it's possible. Let's try U32 then. Because I'm still not 100% convinced about the alignment. I don't know if that alignment is correct or not. Okay, first of all, what is my fucking DTD returning? It's returning a U64. And what exactly are we as the total is here. And what am I adding? Size and sizes too, and I'm doing some lot of random stuff to convert that size. Oh, I am not convinced. Let's just put 32 here. So at least we have to only worry about one side of it. But now I have to change every damn thing. Oh, fuck. No, that's not going to work. Because that's exactly why we are getting 0 when we try to print it, because I think the entire 64-bit is somehow shifted. Maybe we'll shift it to 8 bytes and see. How can we do that? No. Somehow the alignment is fucking with me. So the value... Okay, let's break at K-main and try to do something. We have to get this working. We can. Only thing we have to do is it's disassemble K-main and take this and start here 3 4 and 3 4 and enter. Now we are here. We don't care about the first instruction, but here it does not seem to be taking x0 value. Somehow it's able to read the x0 value without even having to read x0. How is that? Because the x0 value is this. But it's taking it from the stack. Okay, so what's before this? Why is my... Is this the correct way to pass an argument to the function? My function accepts a U64 value. So this is the correct way because x0 to x7 is the correct one. I know that, so it should be correct. Move. So that is correct. Maybe it's simply not using that. I have to move to this function call. That would be even better. Assemble this, and it is using x0, so it's correct. And we are storing x0's value into x29 minus something, whatever. And x1, what do we have at x1? I guess it's some character. And we get into the printf. And printf is long thing. I cannot get through it. And I don't have a stack frame to press finish either. We have to think in a better way. What can we do? What can we do? Yep. We could just comment this out so we don't have to worry about that. So we'll directly get into the processing, and that's where the things are actually happening anyway, so that's fine. Assemble init an application. Oh my god, not that. Continue it. Now we have the actual, we are taking x1 value, we are storing it somewhere, and we are storing x8 into somewhere. Okay, what exactly is that? X29? What is that thing? It's an address. Okay. Okay. Mm, now what can I do? This is the call to this fucking thing. Memblock. So by now, whatever in x0 is the argument for that, and it's still, but that's wrong, because maybe it's just going to do it. Let's try. Now if we try x0, okay, it's 2000, so it has calculated it. Okay, did we calculate the same thing? We calculated it like this. This is the value that we got out of it. Oh my fucking god. Oh, it's just so fucking annoying. That we don't literally do anything. We just check if a instruction is something. That's it. Okay, we can do that. Let's try to make it as UN 32 value. No, what will we get? Still 0. Still fucking 0. Let's try this. 64. Total RAM equal to, let's assign the value that we want to see. That way we can see the difference and come to a conclusion. It's 8,000, I guess. Oh, I fucking forgot. I guess it's 80,000. Okay, this is the value that we want to see. No, we want to see just 1000. What exactly do we want to see? I fucking forgot. Oh shit. I think we want to see 4 GB. That is GB. Two. The fuck? Oh crap. No, 4 GB in bytes. 4 GB in bytes. Not exactly. Is it? It's fucking so fucking annoying. Let's just fucking see it from there. At this point I'm fucking too much night. That's the brick. I broke here, and let's just examine x0. x0 is this. Maybe if I get just that. Okay. This is what we want to see here, so let's put hex total RAM equal to this decimal, big decimal number. Now if we quit it and restart it, or restart it and put the breakpoint, we won't exactly stop at that location, did we? Okay. X. What? No, I guess I have to do it slowly. Disassemble unit and no, disassemble. Let's 3 came in, and I want to stop here. continue, and if I try x0, it's the same thing. So we are reading it correctly. Then why the fuck it's not working? What the fuck? Is my fucking print wrong? Where's my fucking prints implementation? Well, let's double check it. This is the function, and we have passed the new total RAM value. A new total RAM value is just this same thing. So it is correct. Even if I remove this part, it's going to be the same thing. Oh my god, it made me question everything, and it's finally saying it's correct. Oh god. No, 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 no. Whew. This Yamamio is just making me. And if I try 0, it's correct. So we don't have to worry about alignments. It is correct. We should not question our instincts. We have passed it correctly, and the value is in here in a proper way. So now our UART is wrong. UART is not able to fucking, because it's a pretty hacky solution. Oh, okay. We are now for 32-bit integers. Oh, my fucking code fucked me up. I questioned every damn thing. And it's still fucking not working. Why? Okay, maybe I have to remove this fucking thing. Still not working. Oh god. Where's this? We are here. We get the format. We keep going, and whenever we see a D, we check the format args. This is not even possible. I don't know. Just do it. And I think this is what is happening here. D is equal to 0. Why is D considered as 0? Is this format args? Mm. Well, we are using the denominator, the remainder approach. But first of all, the value needs to be something that is not 0. Only then it will do whatever we want it to do. Now it's time to ask GPT. This works for int, not for int 64. Use that in each cases is not considered here. I fucking missed this. But still, I think it is written in here. We didn't even come here. I don't know. No, yes, we didn't even come here. We are here. I am pretty sure about that. You are put C K. See, if I run it, what? I have an error. Cannot open UART 0. Why? Oh shit, show. It's a shit show. See, it's K0. We are here. We are fucking here. We are here. D value is 0. Why the D value is 0? D is here. What is D? Oh fucking hell. I'm a piece of shit. Oh fucking god. What's the Let's implement this. What is the format string for uint 64? It's LLU. It's LU. Okay. Then let's implement that, and we can also have a normal d value, so it should be d. D is fine. Let's put L. D is just int. And we copy 3 lines, we paste it here, and we place L here. If it's percentage L, then we click L equal to this. Now if we can go back and change this to back to int, and let's change this back to L. Now we have support for normal int and normal TL, and we also have to change this entire thing. Let's start from here. Let's copy the whole thing and we yank it and we paste it here, and we can change it, and we uint is going to take 64-bit value. And if we come down, is there any other cases? It's everything's uint. And for normal integer, let's change it back to let's change it back to int, and also let's remove this we need the edge case here, and we have it as int here. Okay, I guess we added support for, we have normal int to str, and we also have uint to str. And so if we no what did they fucking change? Oh fucking god. Just remove this and okay, now it's good. We have int that is completely int, and we have uint that is completely uint. Now we can change the call back in print, saying we have a int d and uint l, and it's going to take int, and we just change uint. Oh fucking god. Oh, that's it. Now if we use, where's our key name, we could just use L here. It's It's our own fucking format specifier. We don't fucking care about printfs. If they use LU, we will use L. And it'll work. Now we have the entire total RAM. We divide it by 496 and divide it by 8. And we pass that value to bitmap size. Okay. Now let's print that after this. And it's total bitmap size. This is fucking annoying. I put DW and bitmap size. I've written it. Now if we run it, we have bitmap sizes that. Now if we go into our main block, we change this to uint 64. Now let's see if hopefully this fucking thing works. Still we get the same fucking error. Why is this size greater than? How is maybe uint 64 current max equal to, no, it's not max. Where is the value? Uint 64 max equal to this, and put max. Why is it still not working? It's 1 2 3 4 5 6. 1 2 3 4 5 6. How come this size can be greater than max? Max is just 52222. What the fuck? Let's just try. I'm fed up. I need answers. I need fucking answers. It still says allocation fails. Even with this. Or maybe I'm completely wrong. We have already crossed it. And that value is 0. There's no print UART. Let's just try 2 here and double check it. What the fuck did I miss? Okay, it does not like that. I'll put void star You should like that. Your C. You should like anything I throw at you. See, now it's working. So the error was not here. I'm fucking stupid. The error was here. The error was that I was not able to get this thing properly. It's extend uint. Where's it? Where's the damn thing? It's here. And it should have, I don't know what. Maybe it should be, I don't know. It's an address. So let me just take it as UN64. And we convert it into white star. What about now? Even now it failed. Let's extend it here and we'll print it. Let's see what the fuck is that. You want to print test L/n block start. It's fucking 0. And what else am I expecting? If it's 0, it will be 0. Starting address is this. I align it. Something is wrong. It's BSS start. BSS end. We add some bits. We again start. Why? Why? But why? Why are you fucking with me? What did I do? I wasted 1 hour wondering why my UN16 does not have the proper value, but it turns out my fucking block memory start was 0. Oh, fuck me. Ah, shit. Now what do we do? There must be something. There must be something. How can we import that value? Because we are importing BSS here and it seemed to have worked. Okay, let's just move that out of BSS. There's no particular need to be. It has to be in. Okay, let's try this. Maybe BSS is bullshitting me. Oh my fucking god. Wait. info files. Info files. Maybe I should consider this as not as a value but as address. Even if it was something, if I make it into U64, it should show some values, right? How to import this block labels into C? See, we could use just UN64. It should work. Well. Returns 0. My fucking declaration is wrong. Dude, I had it as unit 60. Okay, I was wrong. Now let's see if your version is working or not. Let me just make it as this, and then I'll add unit 64 here. If I cast it, is that enough for you? No, it didn't work. It did not work. No, something else. Okay. I have to place a fucking. That's why I made it like this in the beginning. I don't know. What's the difference between this and putting a char pointer there? There's no fucking difference. Oh, this is how I initialized it in the beginning. Putting in the front Putting a thing in the end does not matter. You fucking moron. I don't fucking know. I don't fucking know. Start. Okay, let's see. What? It worked? Shit. Maybe because I removed, there were like two different extents, that's why our fucking linker got confused. That's why I removed it here and I only kept it here. But if that's the case, it would still be the same, because what I did was I just initialized it like this. Uint star. Why is uint star not working? What is the difference? We are saying we have an array of uint 8. If I put star, that means okay, I need to put this. Will it work? No, didn't work. Maybe I'm fucking fundamentally wrong. Between uint 8 star temp versus uint 8 test. Okay. This is the fucking issue. For linker scripts, we are supposed to like what about argv star 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 argv? This is argv because this is what I remembered. It's star star argv. Fundamentally wrong in some way. I need to understand this fucking thing. What does it expect? It's expecting an uint array. If I have an uint8 array, isn't that equivalent to saying uint star uint8 star something? This will be the first value in that array, and we can pointer index to use that as array, because this is how I know it. You create in storage, so I am correct. No, I'm not correct. No, I am correct. See, if you, because that would be the first index in the array. That's how I remember it. Yeah, it's equivalent to just indexing it. Yeah, I know that it won't create memory because I know I have already created the fucking memory. This is already created and there's a space here. So if I just use the top of that index, I could just index into it as long as I want. But the address block is already assigned in the linker. So if I just take the address of the top of that block, shouldn't that be enough? Because I could just use pointer indexing to index into that block, because that was my understanding. That's why I thought I could just take this as an pointer and I could index into it. Yeah, linker already allocates the block. So in C, you only need to take the address and you can index it. But the key is you must declare the. Everything is correct, but it's just that I should not take this as an address and think about pointer operation. I can think about it in that way. It's just that I don't know, for some reason I have to assign it, allocate it as this. Oh, fuck me. Hmm. Okay, I have learned something new. So if it's in a linker script, we can't simply just take that as an thing. We also have to make sure that it's initialized or it is declared properly so the Z knows that it's an array. But if you just take it as a pointer, I don't know, man. What if I give somewhere? I guess I have to declare it. That was the key error. Okay, okay, not bad, not bad. Not bad, not bad. Now I have to wonder if it is just fucking hallucinated or not. I don't know. But it seems reasonable. But my understanding is still fucking with me because there is a block and I have the pointer to the top. Why the fuck do I need to initialize it is it as an array? I don't know. Okay, okay. Let's just see. Let's just see. Now what? Dude, I just fucking went through that, all that fucking. Okay. And I didn't. I went through all that and I didn't learn anything. Ah, shit. It's a shit show. Okay. Now it's allocated. Now it's allocated. Now we are returning it. And boom. Boom, boom, boom. We have a thing. Now we can say that what can we say? What exactly can we say here? Yeah, now we have the bitmap. We can say that every bit maps to an page. So if we have to write a helper that's just going to keep track of this. So if someone comes and says I want X space, it has to go through this bitmap and find a new bit that's not yet assigned. and assign it as already used. That's it. Yep, yep, yep. I guess that's enough for today. We'll do that later. We fucked up a lot of stuff and we wasted a lot of energy. Mm. Anyway, it was whatever we have learned two things that we can pass variables with x0 and it should work fucking fine. And the second thing is that just because you declared something in your linker script doesn't mean it will. If you just take the address of this, does not mean it will work. We have to initialize it properly so that the fucker knows that it's a fucking block of array, and then you can do whatever shit you want to do. Yeah, that's it. Have a good day, guys. We'll see probably in the evening. Thank you.